this is a solution we actually monitor in real time, and this real time is going to make more sense because this is a very context sensitive term. For me, even 5 minutes can be real time. For somebody, a microsecond is real time, right? So when we look on the switches, the metrics are collected as soon as an exchange completes. In fact, we'll go down in detail that when a metric is collected, some of the metrics are collected even before the exchange is completed, right? So this real-time term is very, very flexible. But when we look at these metrics, we are humans, so we can be only so fast. At least I can't work at a microsecond scale. So for me, a couple of seconds is real time is good enough. But when we export these metrics to DCNM, it's going to be a 30-second export, or streaming interval. That's the technical word, streaming interval, 30 seconds. But then folks are not going to be sitting in front of the screen and then watch every point every 30 seconds, right? So that's why we have a post-processing there, which happens every 5 minutes, right? But you still get to see metrics every 30 seconds, right? We'll cover all these details where things fit, but I just want to be clear that when we say real time, a lot of times people ask this question, hey, do you do real time? And I'm thinking, well, how do you define real time, right? Because the kind of problems that we can solve with 30-second streaming interval or 5-minute visualization, I mean, you can still achieve that 80% goal, right? Still solve 80% use cases by slight variations in these so-called real-time misnomer. And the last bullet about vendor neutral, we already talked about that, but essentially we are not hooking into anybody's APIs. We are looking at standard-based SCSI and NVMe IO transactions. So as long as the end devices are doing standard base, we get to see those. That's a great thing, but then there's a downside of it. If they are vendor-specific exchanges, we don't see that, right? So watch out for that. I think this is documented somewhere, but I think just yesterday, somebody asked that, hey, I want to monitor my SRDF traffic, and like, okay, we're not going to do that, right? That's vendor-specific, that's EMC-specific, we don't do that, right? So there are pros and cons of doing this approach. In the future, if there are requirements, we may add some vendor-specific attributes, but none of that exists today, at least by the end of 2020. Okay, and what happens when the switches collect the metrics? We export them in open format. These are open formats, so anybody who can or who has the capability to ingest this traffic and do some magic over it, feel free. But officially, we have two solutions. One is DCM SAN Insights. You kind of saw the demo yesterday. And the other official solution is Vertana Virtual Wisdom. By the way, Vertana is the new name for virtual instruments, right? So we are going to use them interchangeably because we still like to, like as a habit, we call them as virtual instruments, but Vertana is their new name.
Baresh, one question. Since you were mentioning EMC SRDF replication tool, just to understand, we do not monitor specific attributes from EMC SRDF, fine, but can we still use SAN analytics on replication traffic only?
Well, it depends, Fausto, that if they are doing standard base transactions, the switches can still inspect the traffic and report the metrics. But honestly, that's not even our use case. That's not something we want to chase as a business direction because if I go back to the original, I was talking about that all flash and NVMe traffic, my application is accessing storage and it's getting slowed down. Why? That's the basic question that we're trying to chase. If the replication is being slowed down, right, like, we want those replication vendors to answer that question. Also, the way market has been working, it's going host-based migration. People are storing their backup data at a lot of places. So that's not the use case that we want to actively chase.
Okay.
So it may work. I'm not saying no, but like be aware of that. That's not something, we want to lead with. that if somebody says my replication traffic is not performing, or like, okay, yeah, this is not the best solution for that use case. Okay, talking about solution components. So I talked about this yesterday, but essentially it's very important to understand these things, that there are 3 separate components. And I'll show you that in like probably in the switch right now, that the first component of the solution is SAN analytics. And by the way, we overload the terms, right? Cisco SAN analytics is the name of the overall solution. And by the way, SAN Analytics is also the name of the feature on the switch. We enable that feature on the switch using the command feature analytics. This feature inspects the traffic and it collects the metrics, but then that's it. It stops there. And there's a separate feature called SAN telemetry streaming. Sometimes people call it as STS, other name is streaming telemetry, or just the telemetry. Call it whatever you want. But this is a separate feature to export the metrics, right? And when you export the metrics, the question is where you're going to receive it. So from Cisco, we have DCNM, and within DCNM, we have an analytics engine, which we call it as SAN Insights, right? So these are 3 separate components. And let me show that like real quick, because it's important to realize that, because a lot of these things depend on these things, right? Like a lot of those small little answers that you're going to be looking later, if you divide these whole solution into 3 buckets, it's going to be easy for us to understand, right? So there is a feature analytics, right? This is a separate feature. If I enter it, it actually enables that, or enables that process which is supposed to inspect the traffic and collect the metrics. Now, this is different from feature telemetry, right? Now, feature telemetry is, as I said, it's an export mechanism, right? If I try to run a parallel, think about SNMP, right? SNMP has the capability of exporting a lot of data, but it doesn't really necessarily go in the ASICs and collect those data points, right? It just exports it via OIDs or traps or one of the things, right? It's a higher level construct, which is an export mechanism. A kind of like, parallel with that. Not exactly, but that's one way of understanding it. Right. Also, if you do show running analytics, you'll see, crazy things like these. Don't worry about that. We'll cover them later. But you'll see that within the interfaces, we have enabled these commands essentially to inspect and collect metrics from SCSI traffic and from NVMe traffic. But as I said, if you just enable analytics on the switches right there, all you can do is visualize those metrics on the switches. We are not sending those metrics anywhere. To export the metrics, obviously you need something like this, all right? Don't worry about that. But in addition to that, you also need something like this, configuration under telemetry to tell the switch that send my metrics to this IP address on this port using gRPC protocol and use the encoding of GPP.
So if we just enable the feature telemetry but not the analytics, what sort of telemetry is available at that point if not the analytics?
So we also support interface metrics. Right, let me now that you've asked this question, and it's a quick one to answer, so I can answer that right away. The interface metrics that you probably like, packets in, packets out, errors, TXB2, B20, TX weights, all those things can also be exported. And we'll cover that in module 10, probably towards the very end, if the time permits. So these are 2 kind of metrics that we support. Yeah, you see this, right? Like you need to create a sensor path here, and you need to provide the path like show stats FC slot port. So when you configure this, I'll show you a demo of that like later, but probably next week. When you configure it like that on the remote receiver, you can receive all the metrics that you get within show interface counter, let's say details. These metrics that you see here, all these metrics will be reported there. but then there's a separate config for it. So to answer your question, today using streaming telemetry on the MDS switches, we can export two types of metrics. Number one, the SAN analytics metrics, or in other words, IO flow metrics. These metrics are about end-to-end exchanges of read and write traffic. And the second type of metrics are the interface metrics that you have been seeing before. Traditionally, we have been exporting these metrics via SNMP, but we can export them via streaming telemetry also.
Great, thank you.
And next week, we'll also talk about some recommendations that which method to use when, because you can do this SNMP, you could do SSH and parse this thing. You can do NX API, right? So which is the method recommended thing and which one to go where, right? If somebody's building something of their own, right? So we'll talk about those recommendations next week. Okay, I guess I've talked about these things. Simplicity, the last bullet is, yes, I mean, you saw those single commands. Essentially, it's one single command that enables traffic inspection and metric collection on a switch port, right? That's how, you know, we convey the point of simplicity. If you compare it to any other solution, even you have to configure a flow that you want to monitor, right? And I mean, how do you come to know about a flow, right? Similar to a TCP flow, think about that. If you have to figure out where is my source port number, where is my destination port number, source IP, destination ID, upper layer protocol, all these stuff. And then you keep on configuring it. If you want to monitor 100 flows, you configure it 100 times. Guys, that's not simplicity, right? Here, you're going to see that nobody cares about what those flows are. By the way, this is fiber channel, so there are no source port, destination port here. We talk about ITL or ITN flows. And this is one of the coolest thing about this capability, which totally go unnoticed because it has been there since day one, is that we learn the flows, right? First is the learning phase, and then is the second is the metric collection phase. So that's where the simplicity comes in. Okay, the second piece is about SAN telemetry streaming. Essentially, if you think about why did we bring this capability, you know, for those of you who have been working with other teams also in Cisco, probably if you have been following that, I think the XR team on ASR 9000 routers was the first team to came up with this capability on any Cisco product. And their use case was very different because they have customers like service providers, right? Like the guys who run internet in this world. And they want to monitor their device, like the core router on the internet. And the use cases are like, I want to download the internet routing table, right? So that's a crazy scale. So if you think about, you know, our traditional monitoring mechanisms like SNMP, like any API, doesn't scale at that level, right? And we have some, you know, some testing numbers that what happens if you export it via one mechanism versus other. If we try to export the numbers that you see on the slide, which is 40,000 flows and then 70 metrics per flow, that we're talking about like 2.5 million metrics at every export. If you go via SNMP, there's just one thing that's going to happen. We'll kill the switch, right? High CPU, and it will never come up until there's some major disruption. So that's why we don't even support this capability via an SNMP. And we had to come up with, you know, streaming telemetry, which is an extremely optimized approach of exporting this. Also, we'll cover some details that there are, the gRPC is actually a protocol that runs over HTTP. And then how do you encode the data within itself is a different question. So there are different kind of encodings. One is the KV format, which is a key value, right? Like nothing but a key value, a dictionary, or any other way you want to remember it. Like key value is something like, this is my packet in, and this is the value, let's say number 100, and this is my packet out, and this is my number, which is 200, right? So this is key value. However, the idea is to make it even more optimized, and that's where the compact encoding comes in play, which is essentially the binary format of exporting the metrics, right? Very quickly, on MDS switches, it brings the optimization 4 times, right? What I mean by that is we have a management port or 1 gig, which is used to export these metrics out of the MDS switches. And when we use the compact GPB, we bring down the utilization of that port by 4 times, right? And then there's some commands on the switches that we're going to go cover later that will show you what kind of, like how many messages you send, how many chunks you send. And when we go and use compact GPB encoding, we bring in optimization of 4 times, right? By the way, that's the only encoding we support at scale on MDS switches, because I mean, somebody asked this question yesterday on the WebEx Teams that can we export these metrics via front-end port on the MDS switches? Well, MDS is a fiber channel switch, right? So unlike Catalyst or Nexus, we can't really have a 10 gig front-end port on a module connected to our management network, right? We are limited to our supervisor management ports. And then I mean, honestly, I haven't even come across one single customer who is ready to invest more in that management network. They want more, but they don't want to invest in that direction, right? They want to invest in their front-end port capability. So because of that, we had to take this decision of exporting this metric via the management port only. And because of that, we only support this export via compact format if you are trying to scale. Now, later I'll show you a demo. For demo purpose, let's say if you have a couple of thousand flows, you can export via KV format also. You don't have to go compact. But let's say if you're talking about 40,000 flows being exported all the time with all the metrics, don't do anything but compact encoding, right? It's extremely important, right? While we're talking about that, because there's so many thoughts that keep on flowing through the brain, and I want to keep it total informal. If you go in the config guide, at the very end, you'll see something SAN telemetry streaming protofiles. Now, for those of you, I mean, who are already, aware of these things, it's great. I just want to point there. If you're not, don't worry about that. If at all you come across a customer who asks you the detail, that, hey, how do you make it happen? Point them here. If somebody is asking that question, I assume they have a development team who can figure it out. Like folks like these guys are the customers who have been asking about it. And they have those resources to invest in this direction. They already have these kind of protocols running in their environment. They can make sense out of it. All they require is this encoding file, right? It's essentially, a lock and key mechanism, just like encryption, the way encryption works, right? Like you have a key on both the ends and then you send encrypted traffic. The other guy just unlocks that encrypted frame or encrypted message. It's something like this. If you look at this profile here, we assign these IDs like port is 1. So in a very simple term, if you think about, we don't send port anymore because port is 4 characters. It takes more space. Instead of port, we send 1 because 1 is 1, right? Like 1 is like 1 bit, right? So that's how we compress. If you look at like long strings, instead of sending the long strings like this one, this is a really long string. It's going to take a lot of space if you try to send it over wire. And by the way, multiply everything by millions, right? But instead of that, we just send number 23, right? This is a very simple way of understanding it. It doesn't work like this, by the way, right? I want to be technically accurate here, right? I'm just trying to give you an example that this is how we convert the metrics to the numbers, and then we compress it and send it over. And that's why you need this file sitting on your receiver to decode that incoming message, because the switch will say number 23 equal to 1,000,000. And the receiver must be aware what that number 23 means, right? So the number 23 means SCSI initiator entity ID flow count. Okay, moving on, SAN Analytics and SAN Insights. Essentially, as I said, it's an analytics engine within DCNM. If you think about the value of it, like, we could have made a different application, but customers have been asking that I want a single pane of glass. Like, I don't want to go to one application to monitor my switch ports and go to a different application to monitor my IO flows. And I think that's a big value of DCNM, that it's the single application that provides the end-to-end visibility. Okay, when we talk about requirements, what do you need to enable this? Essentially, you need a 32 gig capable MDS switch. You need a license on the switch, and then you need a so-called supported NXOS version. Now, always refer to release notes. Don't look at the slides. After 6 months, the slides will get old, right? So really refer to the release notes for the exact details. As of now, as of today, which is September 2020, you see NXOS versions, refer to that, but in the future, refer to release notes. Also on DCNM, always go with the latest version. I'm saying 11.1 onwards, but as of today, the latest is 11.41. Go with that if you're trying to deploy it, but pay special attention to the DCNM requirements, right? And I know there have been a lot of complaints about that, but guys, this is what it is, right? And we as a team collectively, we have to think about how do we make successful for our customers, right? I'll tell you some details. I know, Wolfgang, you have some stories. I know a couple of other folks, you have some stories that you enabled it and like, created some issues, but we'll walk through, right? If you enable it the way Art showed you yesterday, don't do that. Don't just go like deploy everything, go on DCNM and enable SAN analytics. Nope, don't do that, right? We'll walk you through how to do it, right? In a more graceful way so that you don't land into those issues of flows being bombarded on DCNM and going beyond the scale limit and bringing everything down. Okay, I skipped a couple of slides because we talked about this yesterday, and essentially, I think it's very important to understand that what this solution is not, right? Number one, it's not an inline traffic analyzer. Inline traffic analyzer. Using Cisco SAN analytics, you cannot get a trace, or you cannot get the dump of the packet or the dump of the header. That's not the intention. That will never happen. You can make a request, but I'll tell you right now, that will never happen, right? Because that's not something we want to chase, right? That's a problem that is best solved by the inline traffic analyzers, and we should walk in that direction. I know this has happened before. In the very beginning, couple of customers were told like that. They deployed and there were CSAT issues. We don't want that to happen anymore. That's number one. Number two, Watana offers splitter, optical splitter-based tap solution. And even though both Watana and Cisco have been saying that, the integrated analytics capability and the telemetry capability of the switches can export those metrics, but don't just blindly replace those optical taps. There are use cases for that, right? So if you are under confusion, talk to the Watana folks or talk to us. It requires a detailed investigation that what use cases customers are using, because some customers are just using 20% of the capability of those hardware taps. Okay, so be aware of that. Number three, do not use SAN analytics as a performance benchmarking tool. I've heard this a couple of times. People say, oh, my customer is getting the new brand new all-flash array. Let's put SAN analytics and measure IOPS. Guess what? Don't do it, right? Number one, something goes bad, or let's say the customer doesn't get the IOPS that they expect. You don't want to get in a battle with our OSMs like, look, Cisco solution told me that the IOPS is low. Right, that's a very bad stand. That's not our use case. We don't want to follow that. Number two, later I'll talk about some of the limitations, right? So it is possible if you exceed those limits, your metrics would be wrong. Some of the metrics would be wrong. Not all the metrics would be wrong. Some of the metrics may not be accurate. There's a difference between wrong and right? It's not black and white. There's something, those shades of gray in between. So where you fall, we'll cover those details, but overall, stay away from that whole messaging that, no, it's not a performance benchmarking tool. There are tons of them out there. Go use it. This is trying to provide you visibility in your production traffic and try to solve the problems for you. It's not trying to give you those numbers, those plain numbers, that a million IOPS number, right? And number four, I know a lot of times we want to use SAN analytics for solving slow drain, but we have the expert right here on the call. He just spoke a few minutes back, but when we talk about the strict definition of slow drain, it's about the exchange of credits, the frame flow in a fiber channel fabric. It's not about what happens between an initiator and a target, because B2B credits are linked local, right? And by the way, we already have very strong capability on MDS switches. You can watch the recording that Ed Cisco live session, or we can ask him to present one more time for all of us. But that's something important to understand, that when we say that SAN analytics can help you to find those performance bottlenecks, but just saying that it helps you to detect slow train is like, no, okay, now we are playing on the edges, right? Because if SAN analytics tell you how long your I/O is taking to complete, like how long your read command took to complete 200 microsecond, that's not really a good indication whether there was a slow train or not, right?